Okay, we're going to go over some problems that were on a recent exam. The first one is to explain why cos squared theta plus sine squared theta equals 1. The thing to remember is we have a unit circle. It means all of these points lie in a circle with a radius of 1. So the radius is 1. If this is the angle theta, the x value is cos theta, the y value is sine theta. Now, what do we know about a circle with radius 1 centered at the origin? It's x squared plus y squared equals radius squared. The x squared is cos theta. Cos theta squared, the y value is sine theta. Sine theta squared equals 1 squared. Now, again, that's true wherever you are, right? The x value is always cos theta, the y value is always sine theta. So that gives us our favorite identity, our Pythagorean identity. Cos squared theta plus sine squared theta equals 1. For our next example, we want to do a proof. So we are starting with secant 3 pi over 2 minus theta. That's my left-hand side. Left-hand side equals that, which of course is 1 over the cosine of 3 pi over 2 minus theta. Cos of A minus B is cos A cos B plus sine A sine B. So cos 3 pi over 2 cos theta plus sine 3 pi over 2 sine theta. Which in turn gives me 1 over 0 times cos theta plus negative 1 times sine theta, which gives me 1 over negative sine theta, which is negative cosec theta, which is the right-hand side. Next up, I want to find an exact value for the sine of 165 degrees. I'm going to use the sum rule here. So I'll go with sine 120 plus 45. Those should be two that I know. Sine of A plus B, sine A cos B plus cos A sine B. So sine 120 cos 45 plus cos 120 sine 45. Sine 120 is in quadrant 2, same as sine of 60. That's positive, so that's root 3 over 2. Cos 45 is root 2 over 2. Cos 120, again, second quadrant cosine is negative. So negative cos of 60, so that's what, negative 1/2, times sine 45, which is root 2 over 2. So we get root 6 over 4 minus root 2 over 4, which we could write as a single fraction if you prefer. Root 6 minus root 2 over 4 is what that becomes. All right. Our next question is pretty complicated. So what we have here is, this is what we're given. We're given sine of S is 3/5. And we are given cos of T is negative 12/13, and we want to find sine of S plus T. We want to find cos of S minus T. Well, to do that, I need to find some other things here. So I am telling you that S is in quadrant 1. So knowing that, what can I say? Well, we know, of course, cos squared S plus sine squared S is 1. So cos squared S plus 3/5 squared is 1. So cos squared S plus 9/25 is 1. So cos squared S is 1 minus 9/25. What do we get here? 1 minus 9/25 is 16/25. So, but I said S is in quadrant 1, so that makes cosine positive. So cosine S is positive square root of 16/25, which is 4/5. Next up, I'm saying that cosine of t is negative 12/13. And, what do we know about this? T is in quadrant 3. So let's go ahead and make that note. T is in quadrant 3. So I need to figure out what sine t is. So again, I'm going to use my identity. Cos squared t plus sine squared t is 1. Cos squared t, negative 12/13 squared plus sine squared t is 1. So 144 169ths plus sine squared t is 1. Sine squared t is 25/69ths. 1/69ths. T is in quadrant 3. In quadrant 3, sine t is negative. So sine t is negative square root of 25 1/69ths. So sine t is negative 5/13. So we have that. I need sine of S plus t. I need cos of S minus t. So let's take a look at how that's going to behave. Sine of S plus t, sine cos plus cosine, sine S cos t, plus cos S sine t. Sine S is 3/5. Cos t is negative 12/13. Plus cos S. Cos S is positive 4/5 times sine t, which is negative 5/13, which gives us what? Negative 36/65 plus negative 20/65, which will give us negative 56/65. And similarly, we need to figure out cos of S minus t. So cos plus sine. Cos of S minus t. Cos S cos t plus sine S sine t. Cos S cos t. Cos S is 4/5. Cos t is negative 12/13. Plus sine S is 3/5. Times sine t is negative 5/13. Which gives us negative 48/65 plus negative 15/65, which equals negative 63/65. All right. Our next question requires us to figure out some half angle things. So we're told theta is between pi and 2 pi. And we're told that cos theta is pi over 4, is 1 over 4. We want to find sine theta over 2, and we want to find cosine theta over 2. So let's go through into that analysis. Well, what else do we know? We know that theta is between pi and pi over 2. That means it's in quadrant 3 and quadrant 4. Cosine is positive, tells me it's got to be either quadrant 1 or quadrant 4. Therefore, theta is in quadrant 4. To make both of those statements true, that's the only way that can happen. So that's helpful. We are going to use our half angle identity. So let's take a look at how that's going to work. If we divide by 2, pi over 2 is less than theta over 2 is less than 2 pi over 2, which is pi. So where does that put me? Theta over 2 is more than pi over 2 and less than pi. It puts me here. So that tells me theta over 2 is in quadrant 2, which is helpful. So let's go ahead and figure out what sine theta over 2 is. In quadrant 2, sine theta over 2 would be positive. And the formula is 1 minus cos theta over 2. So it's positive square root 1 minus a quarter over 2. So that's 3/4 divided by 2, so that's 3/8. So it's plus the square root of 3/8. Root 3 over root 8, which is root 3 over 2 root 2, which is root 6 over 4. And then for cos theta over 2, again, theta over 2 is in quadrant 2. Cos theta over 2 would have to be negative. In that situation, in quadrant 2, cosine is negative. So what are we going to say there? 1 plus cos theta over 2. Negative square root 1 plus a quarter over 2. So that's negative 5/4 over 2, which is 5/8. Negative root 5 over 2 root 2, which would be negative root 10 over 4, if we're looking at it that way. All right, next we want to figure out an exact value for the following. We are looking for sine pi over 12, cosine pi over 12. Well, it looks a lot like the identity, which is sine 2 theta, is 2 sine theta cos theta. So if that's the case, that means 1/2 sine 2 theta would have to equal sine theta cos theta. So if I let theta equal pi over 12, then I could say what? Then I could say sine theta cos theta, sine pi over 12 cos pi over 12 is 1/2 sine of 2 times pi over 12. So we get 1/2 sine of pi over 6, which is a half. So I get 1/2 times a half, 1/2 times a half, which equals 1/4. So sine pi over 12 times cos pi over 12 equals 1/4. All right, my next question is a proof. And I'm going to do this right-hand side first and then left-hand side, which is a little unusual. But we have sine of a plus b over sine of a minus b. We want to equal tangent a plus tangent b over tangent a minus tangent b. So here's what we're trying to prove. Equals tan a plus tan b over tan a minus tan b. And this time I'm going to start with the right-hand side. So right-hand side is tan a plus tan b divided by tan a minus tan b. Turn it into sines and cosines. Sine a over cos a plus sine b over cos b. Downstairs, sine a over cos a minus sine b over cos b equals sine cos plus cosine, sine a cos b plus cos a sine b. all over cos A times cos B, divided by the ones on the bottom, sine A times cos B, minus cos A times sine B, over cos A cos B. Invert and multiply, sine A cos B, plus cos A sine B, over cos A cos B, times cos A cos B, over sine A cos B, minus cos A sine B. And you'll notice that cos A cos B's cancel. And this becomes sine A cos B plus cos A sine B divided by sine A cos B minus cos A sine B. Which equals what? Which equals sine A plus B upstairs and sine A minus B downstairs. And that's the left-hand side. So that's my preferred process for that problem. Again, there's many other ways that you could do it. All right, next, we're going to solve an equation. We have cos 2 theta equals cos theta. And we are looking for the answers between the interval 0 to 2 pi. So I'm going to go ahead and use one of my favorite identities. Cos 2 theta is cos squared theta minus sine squared theta. And then we'll rewrite sine squared as 1 minus cos squared theta. Cos squared minus negative cos squared, 2 cos squared theta minus 1 equals cos theta. So 2 cos squared theta minus cos theta minus 1 equals 0. And this is going to require us to factor. So let's do that. Let's factor 2 cos squared theta here, minus 1 here, negative cos theta there. So we get 2 cos theta times cos theta to give me 2 cos squared theta. Let's try a plus 1 here and a minus 1 here, see if that works. 1 times cos theta is positive 1 cos theta. Negative 1 times 2 cos theta is negative 2 cos theta. Sure enough, that's negative cos theta. So I get 2 cos theta plus 1 and cos theta minus 1 when I factor that. So I'll move it over to the left side here. 2 cos theta plus 1 times cos theta minus 1 equals 0. So 2 cos theta plus 1 is 0, or cos theta minus 1 is 0. 2 cos theta is negative 1. Cos theta is negative 1/2. Or on this side, cos theta is 1. Well, if cos theta is 1, theta is 0 or 2 pi. In our interval of interest, we'll go with theta is 0 here. Cos theta is negative 1/2. Reference angle is pi over 3. Cosine is negative in quadrant 2 and quadrant 3. In quadrant 2, it's pi minus pi over 3, which is 2 pi over 3. In quadrant 3, it would be pi plus pi over 3, which would be 4 pi over 3. So my three answers are 0, 2 pi over 3, 4 pi over 3 in the interval from 0 to 2 pi. All right, next we want to find the height of a flagpole. 48 feet from the base, the angle of elevation is 42 degrees. So let's go ahead and draw ourselves a picture of what we have here. 48 feet here. Flagpole with the angle elevation of 42 degrees. We want to find how tall is that flagpole. Well, here's the height, opposite and adjacent. It's a right triangle. So the tangent of theta is opposite over adjacent. So in this case, tangent to 42 degrees is height over 48. So 48 times the tangent to 42 degrees. Tangent of 42 degrees times the height is 43.2 approximately. 43.2 feet is approximately our height on that one. Okay, next up, we are looking for the height of an airplane. We have two observers who are 2,500 feet apart. And we look for the angle of elevation for each. For one, it's 57 degrees. For the other, it's 43 degrees. We want to find the height of the airplane. So they are 2,500 feet apart. One angle of elevation is 57 degrees, and the other is 43 degrees. I'll make this a little longer, so that's more likely to be the case. So this is 43 degrees, and this is 57 degrees. The first thing I need is that angle. So yes, I need the height of the airplane, fine. Heading that way. But I need this angle. We know the three angles add up to 180. So if we take 180 minus 57 minus 43, that other angle has a measure of 80 degrees. So now I have all three angles that I'm working off of. Well, I'd like to find one of the sides. So let's call this B, and let's call this C, which would make this angle B, which would make this angle C. And then I can use law of sines to find the length of side B. So let us do that. So I'm going to say sine B over B equals sine C over C. So sine B, sine 57, over little b is sine C is sine 80. Over C, C is 2,500. So 2,500 sine 57 equals B sine 80. So if I divide both sides by sine 80, I get 2,500 sine 57 degrees divided by sine 80 degrees equals B. So what is that going to give me? That gives me B is about 2129. And now you can see, once I have B is about 2129, now I do have a right triangle here that I can use because I have the 43 degrees here. I have the height of the airplane there. I have opposite and I have hypotenuse, so that could use sine to finish the problem. So using that, we'll say sine of 43 degrees is the opposite, which is the height, over the hypotenuse, which is 2129. So 2129 times the sine of 43 would equal the height. Or the altitude of the airplane, if you get about 1,452 feet, approximately, equals the height of the airplane. And that is that question. All right, next. We are asked to, a person walks east 1 mile, then walks northeast for 2 miles. If he could have walked a straight line from his starting location to the final location, what would have been the straight line distance? So first he walks east a mile, then northeast for 2 miles. So let's draw a picture of that if we can. So east for 1 mile, northeast for 2 miles. If you would have walked straight, what would that be? We are interested in this distance, C. Well, what is that angle? East followed by northeast. Northeast is 45 degrees from north and 45 degrees from east, so this entire angle is 135 degrees. So that would be angle C. Call this A, call this B. We have to use our law of cosines. So what we'll say here is we'll say C squared equals A squared plus B squared minus 2AB cosine big C. C is what we're looking for. C squared is 1 squared plus 2 squared minus 2 times 1 times 2 cos of 135. C squared is 1 plus 4 minus 4 cos 135. So what do we get? We get 1 plus 4 is 5. 5 minus 4 times cos 135. Hit that with the square. We get about 2.798 miles total. So I mean, you could get an exact answer here because we know what cos 135 is. But just to keep it simple, C squared is about 7.828. So C is approximately 2.798 or 2.80 miles. But again, you could get an exact answer if you were so interested in that. Okay, our next question. We have a triangle. We want to find 2 different methods to find the area. We have 44 feet, 29 feet, and 50 feet. So 44, 29, 50. A is 44, B is 29, C is 50. The semi-perimeter, using Heron's formula, is A plus B plus C divided by 2. 44 plus 29 plus 50 divided by 2, and we get 61.5. So the area using Heron's formula is the square root of S times S minus A times S minus B times S minus C. So A is the square root 61.5 times 61.5 minus 44 times 61.5 minus 29 times 61.5 minus 50. And all of that comes down to about 634.2. So that's the first method that I would want to use. So what's another way for us to do this? So again, we have our numbers here that we're dealing with. Let's make sure we draw a picture this time. So again, 44, 29, and 50. Here's 44. Here's 50. Very poorly drawn. Let's try that again. Here's 40. Third time. To draw. 44 first. 50 second. 29 the third time. I'd like to get the angle. Can I get the angle here? So we'll call this angle B. which would make this little b, which would make this little a, which would make this little c. So let's try to find this angle B, and then we'll use that to find our area of our triangle. So using the law of cosines again, b squared is a squared plus c squared minus 2ac cos b. So b squared is a squared 44 squared plus c squared plus 50 squared minus 2 times 44 times 50 cos b. So I get b squared, which is 29 squared. 29 squared is 1936 plus 50 squared, 2500 minus 2 times 44 times 50, 4400 cos b. So we get 841 minus 4400 cos b. Subtracting the 4436 from both sides, I get negative 3595 is negative 4400 cos b. Dividing by that, I get 3595 divided by 4400. This cos b, and that decimal is about 0.817. So b is the inverse cosine of that, and we get b is about 35.2 degrees. So knowing that, we can then construct our height. Remember, the height is perpendicular to the base. So now looking at our picture, what can we say? We can say the sine of b, the sine of 35.2 degrees, the sine of 35.2 degrees is the height divided by the opposite over hypotenuse. Is height over the hypotenuse, height over 44. It gives me about 25.36. Call it 25.4 is approximately the height. And then we'll finish this off by saying area is 1/2 base times height. The base and height are perpendicular to each other. The base here is 50. 1/2, let's call it base times height so we don't confuse the b from before. Area is 1/2 base times height. The base of the triangle is 50. The height of the triangle is about 25.4. Put all these together, what is the area? 1/2 of 50 times 25.4. 1/2 times 50 times 25.4 gives us about 635, pretty close to our 634.2 that we got by using Huron's formula earlier. All right, next up, we want to find the measure of an angle between two vectors. So we have the vector u, we have the vector v. U is the vector 2, 1, negative 3. V is the vector 2, negative 1, 1. We want to find the measure of the angle between them. So you've got to remember u dot v is magnitude of u, magnitude of v times the cosine of theta. What is u dot v? U dot v is 2, 1, negative 3 dot 2, negative 1, 1, which is 2 times 2 plus 1 times negative 1 plus negative 3 times 1, which is 4 minus 1 minus 3, which is 0. So u dot v is 0. How about u dot u? U dot u is 2, 1, negative 3 dot 2, 1, negative 3. So 2 times 2 plus 1 times 1 plus negative 3 times negative 3, 9, 10, 14. So if u dot u is 14, that tells me the magnitude of u is square root of 14. Similarly, v dot v, 2, negative 1, 1, dot 2, negative 1, 1, 2 times 2 plus -1 times -1 plus 1 times 1. 4 plus 1 plus 1, which is 6. Now remember, this is what we're dealing with. We're dealing with u dot v is magnitude of u, magnitude of v, cos theta. U dot v we said was 0. Magnitude of u we said was root 14. V dot v was 6, so v dot v is 6. So magnitude of v is root 6 times cos theta. Well, what that gives me, it gives me cosine of theta is 0. So if that's the case, theta is 90 degrees or pi over 2. So the angle between those two vectors is indeed pi over 2. All right. Next, we have to solve a triangle. And what is a triangle we are trying to solve? Let's take a look. We have C is 30 degrees, A is 8.7 meters, and C is 5.2 meters. Now, if this were AC and angle B, it'd be SAS, but currently this is an SSA triangle. That's dangerous. That could have one solution, could have two, it could have none. So we've got to look to see where this is going to go. So I'm going to start with sine A over A equals sine C over C. Sine A over A equals sine C over C. Sine A, we don't know that, that's what we're looking for. Sine A over little a, 8.7, is sine C, sine 30, over little c over 5.2. So 5.2 sine A equals 8.7 sine 30. So we get sine A equals 8.7 times sine 30 over 5.2. So sine A is about 8365. So one case is A could be the what? A could be the inverse sine of 0.8365. If that's the case, what do we get? We get about 56.8 degrees. The other possibility is A could be in quadrant 2. With an SSA triangle, that's always a possibility. So A could be 180 minus 56.8. Let's see if that's possible. So for our second case, A is 180 minus 56.8. We get 123.2. Well, we started with an angle of 30 with 123.2. That does not put us over 180 yet. So indeed, that's a possibility. So this will be in triangle 1. This will be in triangle 2. So we'll have two different ways for us to do this. Let's go ahead and find out what the rest of them are. So if I want to solve the triangle, there's 6 things I need: angle A, angle B, angle C, little a, little b, little c. So let's start with triangle 1. Triangle 1, again, the stuff we were given, we were told that C was 30 degrees. We were told that A was 8.7 meters, little a was 8.7 meters. We were told that little c was 5.2 meters. And we just figured out that big A, angle A, was about 56.8 degrees. So how do I get angle B? Angle B is 180 degrees minus 30 degrees minus 56.8 degrees, which will give me 180 minus 30 minus 56.8. Gives me 93.2 degrees for angle B. And then I need to figure out what? I need to figure out side B. So I'll figure out side B using law of sines. So sine B over B, or sine C actually would be better, Yes, well, I need both. So sine B over B equals sine C over C. So sine B, sine 93.2 over little b is sine C, sine 30 degrees, over little c, which is 5.2 meters. So that would tell me 5.2 times sine 93.2 equals b times sine 30. So 5.2 times sine 93.2 divided by sine 30 is b. What does that give me? That gives me a little b of 10.4. So I had those four, and then I have big B here, and I have little b here, and I have solved triangle 1. But I also have triangle 2, so let's go through the process of solving for that one next. So what we're given, again, the same starting point. So for triangle 2, we have C is 30 degrees, A is 8.7 meters, C is 5.2 meters, and the other angle, angle A, was 123.2 degrees. So angle B will be 180 degrees minus 30 degrees minus 123.2 degrees. And what does that give me? 180 minus 30 minus 123.2 gives me 26.8 degrees. And then we'll finish this off the same way we did before, using sine B over B equals sine C over C. So sine B, sine 26.8 over little b is sine C, sine 30 degrees, over little c, over 5.2. So 5.2 sine 26.8 equals b times sine 30. So 5.2 times sine 26.8 divided by sine 30 is b. And what did that turn out to be? That turned out to be about 4.69, 4.7 is little b. So there's little b. There's angle b together with the original 4 that I gave you. Solves a triangle, finds all 6 pieces that we need. The ambiguous case, SSA case, that's what we're getting on that one. All right, next. We are asked to solve a triangle where we're given all 3 sides. If that's the case, we're going to need to use the law of cosines. So A is 5 meters, B is 8 meters, and C is 11 meters. So let's go ahead and do that. We'll use the law of cosines version. C squared equals a squared plus b squared minus 2ab cosine c. C squared, 11 squared, equals 5 squared plus a squared minus 2ab, 2 times 5 times 8 times cosine c, that's what I'm looking for. So we get 121 is 25 plus 64 minus 10 times 8 minus 80 cosine c. So 121 equals 64 plus 25, which is what? Which is 89 minus 80 cos c. We'll subtract the 89 from both sides. 121 minus 89 is 32, is negative 80 cos c. Negative 32 over 80 is cos c. That's about negative 0.4. So C is the inverse cosine of negative 0.4. And we get about 113.6 degrees there. All right. Once I have that, then we use law of sines to find another side. So let's do A, sine A over A is sine C over C. I don't know what A is. Sine A over little a, which is 5, is sine C, sine 113.6. Over little c, which is 11. 11 sine A is 5 times sine 113.6. Sine A is 5 times sine 113.6 divided by 11. Sine A is 5 times sine 113.6 divided by 11, about 0.4165. So A is the inverse sine of that, which gives me 24.6 degrees. So we have angle C, we have angle A, we get angle B by taking 180 minus those. So angle B is 180 degrees minus 113.6 degrees minus 24.6 degrees. What does that give me? 180 minus 113.6 minus 24.6 gives me 41.8 degrees. And that is angle B. All right, next, we want to do some work with unit vectors. So I give you a vector W. I ask you to construct a unit vector in the same direction, and then one with length 10. So W is the vector 2i plus 5j. I prefer this notation, 2, 5. Let's find its length. To find its length, I've got to take W dot W, which is 25.25, which is 2 times 2 plus 5 times 5. 4 plus square root of 29 is our length of W. So the unit vector, how do I get the unit vector? The unit vector is W divided by its length. So 2i plus 5j divided by square root of 29, which would give me 2 over root 29i plus 5 over root 29j, or in the other format, 2 over root 29, 5 over root 29. If I want one that's length 10 in the same direction, just multiply 10 times the unit vector. So the second part of that question, 10 times W divided by its length is 10 times 2 over root 29, 5 over root 29, which gives me 20 over root 29 and 50 over root 29. That is a vector of length 10 in the same direction as W. Okay, next one. We need to find a vector perpendicular to 2 other vectors, which is a job for the cross product. So I have the vector U, which is 1, 0, negative 3. And I have the vector V, which is 2, 1, 5. I want to find a vector orthogonal to both of them. That would be U cross V. How does that work? I, J, K across the top, 1, 0, negative 3, 2, 1, 5. Goes plus, minus, plus across the top. So what is U cross V? I times his minor, cross out the row, cross out the column 0, negative 315. Minus j times his minor, cross out the column, cross out the row, 1, negative 325. Plus k, cross out the row, cross out the column, 1021. Do the determinants. 0 minus negative 3, that would give me 3i. 5 minus negative 6, 5 plus 6 is 11, minus j times 11. Plus k times 1 minus 0, which is 1. So I get 3i minus 11j plus 1k, which I prefer to write this way, 3, negative 11, 1. And you could check that that's perpendicular to both by taking the dot product. Take the dot product of this with the original two vectors that you had, and you will see that in each case, the dot product is going to be 0. All right, next up, I gave you a picture of an ellipse, and I asked you to find the equation of said ellipse. So let me try to draw a version of that here. This point is 0, 7. This point is 0, negative 7. This point is 5, 0, 5, 0. Here is our ellipse. What is that equation? Well, span in x is 5. So it's x squared over 5 squared. Span in y is 7. Y squared over 7 squared equals 1. So the equation is x squared over 25 plus y squared over 49 equals 1. That is that one. All right, the next one I have, I gave you an equation and then asked you some questions about the ellipse. So let's take a look at that. Major axis, minor axis, center. So we have x plus 3 squared over 36 plus y minus 7 squared over 4 equals 1. So the center, the x plus 3 means x is back at negative 3, y minus 7 tells me y is at 7. So the span in the x direction, the major axis is in the x direction. Major axis horizontal. So I've got to move 6 away from the center in the horizontal direction. So the points on the major axis would be negative 3 plus 6, comma 7. Negative 3 minus 6, comma 7. Negative 3 plus 6. 3, 7. Negative 3 minus 6. Negative 9, 7. And on the minor axis, I've got to move, that's 49, I'm sorry. That's what I should have said. Minor axis, no, I'm wrong. Let me make sure of that. Yeah, it's a 4. So y minus 7 squared over 4. So we're moving 2 in the direction off of the center in the vertical direction. So my 2 points on the minor axis, moving 2. So I'm starting at negative 3, 7. So negative 3, 7 plus 2, negative 3, 7 minus 2. So negative 3, 9, and negative 3, 5. Those are the 2 points on the minor axis. Okay, we are finally at the last question. We had a parabola. I wanted to know the vertex and 2 points on the lattice rectum, as well as an equation of that parabola. So it looks to me like the vertex is at 0, 3, and the focus is 2 points away, and then it's heading like this. So the vertex is indeed at 0, 3. So vertex is at 0, 3. It's an opening left and right, so that means it's a y squared equals a 4px type of thing. You'll notice the distance here is 2 away. So to find the points on the lattice rectum, I've got to extend the focus up to find out where they are. And the 2 points on the lattice rectum extended from the focus up and down, we get, actually it's below the axis here. I get -2, 7, extended up from the focus, and -2, -1, extended down from the focus. You can see the distance here is 2, but that's a -2 since it's opening to the left. 0, 3, so I'm going to change the y to y minus 3 squared equals 4px, but the p here is -2 because that's the distance from the vertex to the focus is 2 opening to the left, so the p is -2. My equation is y minus 3 squared is 4 times -2x. Y minus 3 squared is -8x. And that will conclude this test review.